Today we're going to learn about dimensional analysis. This is a useful method that we're going to use almost the entire course of chemistry. If you take the time to learn this and buy into actually using dimensional analysis, it will make everything we do in the course much easier since we're going to use this format to solve problems throughout the entire year. A couple things about dimensional analysis. First of all, what is it? It's a way to convert between one type of unit to another. And the second thing about dimensional analysis, you'll also see me refer to this as a factor label method. So this is used with measurements. You see in the photograph there we have someone measuring a super large pumpkin. Measurements are made from the day we're born. So for example, if you're an infant, assess your health, and they're made throughout our entire life. Height and weight are just two easy examples of that. So how we're going to use this dimensional analysis method to look at different measurements. Well, first of all, there's three things we want to do. We want to always identify what the starting units are. What are the units that we're starting with? The second thing we want to identify are what are the units we wish to obtain in the problem. And then the last thing we want to do is know what are the conversion factors to go from the starting unit to the unit we wish to obtain. So the next thing we're going to do is look at the conversion factors. Now this is a table of conversion factors. Now there's really two different categories of conversion factors on here. There's English to metric. Now English to metric conversions will be provided for you throughout the course. I will never ask you to memorize an English to metric conversion unit. So let me just point out a few of those. Okay, one of those that's important is, and then we'll see this in problem today, is a relationship between miles and kilometers. For example, 1 mile is 1.6093 kilometers. Another one is the relationship between pounds and grams. 1 pound is equal to 453.59 grams. So those are examples, or two examples of conversions between the English and the metric system. Now, conversions that I would expect you to know are the conversions within the metric system. Now, these are going to fall into three categories. One's for length, and that would be the meter. One's for volume, and that would be the liter. And then one's for mass, and that would be the gram. So the way this table is set up, it works for any of these three units. So let's say this one stands for meter. So 1 meter is equal to 1 meter. But it also means if you have a meter, 1,000 meters is equal to a kilometer. So that's one of the three conversions I'll expect you to memorize. You'll need to know that throughout the course. It also means 1 gram is equal to 1,000 grams is equal to 1 kilogram. And also down here you see if I have a meter, it's equal to 0.01 centimeters. Now what might be easier to think about it this way is that there are 100 centimeters in 1 meter. And the other one I'd expect you to know, so we got centi there. The other one I expect you to know is milli. A milli, there are 0.001 meters in a millimeter. The easier way to look at that is to know that there are 1,000 millimeters in a meter. So the three conversions you'll need to know is there's 1,000 meters in a kilometer, there's 100 centimeters in a meter, and there's 1,000 millimeters in a meter. And that would apply also for liters, and that apply also for grams. So let's do three sample problems to get us into this. The first one is a conversion using length. Convert 62 centimeters to meters. Now the first step in doing these problems is to look at the conversion table and figure out what is a correct conversion for that. So look at your table now. So if you see on the table that 1 meter is equal to 100 centimeters. Now this is one of the ones I want you to memorize, and it's actually not that hard because centi comes from the word century, and hopefully everybody knows a century is 100 years. So there's 100 centimeters in a meter. So to do these problems, the next thing you want to do is actually write down the given value. So we're going to write down 62 centimeters. Now the next thing we want to do is set up the factor label or the dimensional analysis. In doing this, we want centimeters to cancel. So that means we're going to put centimeters at the bottom. So centimeters is at the top in the given value. We put it in the bottom in the factor label, so they'll cancel. And what we're trying to find, meters, goes at the top. Now we simply need to plug in these numbers. The 1 will go at the top, and then the 100 will go at the bottom. So the next one looks like this. So we say 62 centimeters times 1 meter over 100 centimeters. Now really what you're doing here, 1 meter is exactly 100 centimeters, so it's really like you're multiplying that number by 1. Now when you do this, centimeters cancels out, and you end up with your answer in meters. So the way you do this is you say 62 divided by, anytime it's in the bottom, you divide by 100, gives you this answer of 0.62 meters. So first problem, let's do one more, or two more. How many milligrams are in 25 pounds? So next what I want you to do is look at your table and see what are the relationships, how do you go from milligrams to pounds? When you do that, you may have found there's actually two conversions that are needed. First of all, you look on the metric conversion, and there are you look at the metric conversion, and there are 1,000 milligrams in a gram. So that would be the first one. The next one you look at is a relationship between the English and the metric unit. There's 453.59 grams in a pound. This means we're going to have two steps to this problem. So first we're going to start with pounds, and now we want to convert pounds to grams. Now to do that, we know pounds needs to go at the bottom and grams need to go at the top. So that allows pounds to cancel out. The next step is to change grams to milligrams. To do this, we know grams will go at the bottom and milligrams will go at the top. So there we put grams at the bottom, that cancels, and that cancels with that grams, and then we end up with milligrams. So to do this problem, you multiply 25 by 453.59 by 1,000. And your final answer will be 1.13 times 10 to the 7th milligrams. So a couple things you want to do when you do these problems is always include units. The other thing is we look at this number and there's 3 digits in this number. We're going to learn significant figures later. And so we're going to put 3 significant figures in this number as well. Let's do our final problem. Now this problem is if you're going 55 miles per hour, what is your speed in meters per second? This is what I call a compound unit problem because there's units at the top in the numerator, miles, units at the bottom in our denominator, hours. So we're going to write it in like that. So we're going to start off, and as always, we want to look up the conversion factors. There's actually 4 to these, which means this is a 4-step problem. So first, we're going to have the task of changing our distance from miles to meters. And to do that, we have 2 different ones we look at. First, we see there's 1 mile is 1.6093 kilometers. Then we look at the metric unit, and we say 1 kilometer is equal to 1,000 meters. That's one you need to memorize. The other 2 you probably know, or hopefully know, that 1 hour is 60 minutes, and then 1 minute is 60 seconds. So to start this, first you write your initial value, 55 miles per hour. Now notice I was very clear. I put miles at the top in the numerator and hours at the bottom in the denominator. Now to do this problem, you can start with miles or hours. It doesn't matter. I'm just going to start with miles when I do this. So first I use the first conversion factor. I say 1 mile. Now notice I didn't write 1. Anytime I don't write a number there, it's understood to be 1. 1 mile is equal to 1.6093 kilometers. So this gets our miles to cancel. So now miles cancels out. Next, we want to change kilometers to meters. So we go to the second conversion factor we found up there. And so we're going to put kilometers at the bottom and meters at the top. I put 1,000 meters over 1 kilometer. Now kilometers is canceled out. Now I have changed it to meters. So I'm done with the distance because it said we wanted meters, and I've got meters. Now we need to go from hours to seconds. Now you may want to do this in 2 steps, or you could do it in 1, but let's just do it with 2 here. And so what I'm going to do is put hours at the top and minutes at the bottom. And so 1 hour is equal to 60 minutes, and we see that hours cancels out. Still need to change minutes to seconds, so I have one more step. I say 1 minute is equal to 60 seconds, so the minutes cancels out. And then I'm left with seconds. Then my final answer will be in the units of meters over seconds. Now to do this in your calculator, you should only have to hit enter once. So you say 55 times 1.6093 times 1,000 divided by 60, enter, and then you should have your answer. And notice we started with 55 really has what we call 2 significant figures, so let's only express our answer that same way. Oops, I wrote 24.6. I probably want to round that up to 25. So I'd say 25 meters per second. That's our final answer for that. So look at your notes. If you have any questions, let me know tomorrow in class. Thanks.